live. So, hello stream, hello world. Let's get this going here. So, as you know, I have been, those of you who've been following, I've been working on these sort of toy problems to get more familiar with Clojure. And oh man, I'm so exhausted. I don't know what it is. I keep saying that, but I'm just it's a lot to think about. There's a lot of stuff going on. Head hurts. I shouldn't say it hurts. I mean, I'm grateful to be alive. Grateful for the experience. Things are not perfect, but things are good. Things are good. Overall, things are good. I complain about my job too much, I think. I really do. I complain way too much. I definitely have it a lot better than it could be. Could always be a lot better than it is, also. I'm like acutely aware of that now. But it's pretty good. I should stop complaining. Realistically, really, I should stop doing that. Anyway, the point of this video is let's solve this problem in Clojure. Let's get more practice in Clojure. I said I was going to solve about how many problems? 10 problems total, just to get familiar, and then I was going to move on to the next project. And this is number 6. So I think we'll do 5 mediums after this. This is another easy question, but I think we'll do 5 mediums after this one. Alright, so we define the distance between two array values of the number of indices between the two values. Given A, find the minimum distance between any pair of equal elements in the array. If no such value exists, print -1. Excuse me. We define the distance between two array values as the number of indices between the two values. Given A, find the minimum distance between any pair of equal elements in the array. If no such value exists, print -1. We define the distance between two array values as the number of indices between the two values. Interesting. What does that mean exactly? For example, A equals 3, 2, 1, 2, 3. There are two matching values 3 and 2. The indices of the 3's are 0 and 4, so the distance is 4. Oh, I see. Okay, that makes sense now. Oh, okay, so any arbitrary. Alright, got it. Okay, compute the minimum distances function in the editor below. It should return the minimum distance between any two matching elements. Minimum distances has the following parameters: A, and array of integers. So the minimum distance between any two matching elements. So any element that has a frequency greater than 2 we want to consider, and then we want to find the minimum distance between those elements. Yeah, I mean the simplest way to do that is create a kind of hash map of all of the. Yeah, this can be done in linear time fairly easily, but yeah, it's a pretty easy question I think overall. So what you're going to do is for each number, you're going to use a hash map, and you're going to create at hashed from the index of the key. The object you're going to hash to is going to be you can just use a vector, actually. I was going to say you can use should be like a sorted array or something like that, some sorted list, but it doesn't matter because if you move left to right, then the indices are going to be increasing anyway, and you're going to push the indices that you see that particular value at. So for instance, 7 would be 0 initially, and then the other 7 you're going to push. Looks like 1, 2, 3, 4, 5. So you're going to push 0, 5 at index 7, and then for 1 you're going to push 1, 4, and 3 is going to be 2, and 4 you're going to push 3. Yeah. So you push all those values into your hash set, into your hash map of vectors, and then what you're going to do is take the difference set of, you're going to loop through all of your vectors, and each of them you're going to take, for each of those vectors you're going to take the difference set, right? So it's going to be, you know, for some I, index I, you're going to take the difference between I plus 1 and I, right? That gives you a whole bunch of numbers. Those are the differences between the closest elements, effectively. And then once you've got those differences, you're going to take the minimum of those differences, right? And this is, you're going to do this on each key, and then you're going to take of all those minimums that are left over after each key, take the minimum of those minimums, and that should give you, that should take linear time, and that should also give you the answer to this question. That of all the matching pairs, the minimum distance. Yeah, that's okay. I guess easy enough. Easy question. Easy. Yeah, okay. Alright. This is what it is. This is what it is. So let's code that up in Clojure. So this is going to be interesting. So first thing we want is hash map. So we use a let. Use a let, and then we're going to use a key or key to index indices, and this is going to be this map. You're going to associate, really you want it more or less an into, or a reduction. I mean, either way. You're going to reduce. Now this is effectively a frequency map, but it's not quite the same thing. It's going to be, how does this work? This is going to be interesting. Key to indices, I don't know if I can do this in one line, but I could try. So, be a learning experience. So what you're going to do is, over the range of A, which is this array of the count of A, right? You're going to say, you can maybe say it's an anonymous function. And now the reduce, I don't recall exactly what we do with reduce. I think reduce, yeah, no, reduce is fine. Reduce is fine. We can use this anonymous function, and that's going to take 2 parameters. So we got the map that we're building up, right? The second parameter is going to be the next value, and we're going to say get the default of empty. We're going to get the second parameter, and if it's not there, it's going to be just right the empty. And this is actually going to be conjoined with our new value. Okay, so this is interesting. Yeah, this is actually exactly what we want. All right, you ready for this? So the full explanation of this is, for each oh no, not 2. It's going to be, actually it's going to be just A. Take that back. No, it should be the indices. No, I take that back as well. It should be, okay, looks like this. get, yeah, this looks kind of funky, but it's okay, it's correct. So let me explain what all this is. All right, you're gonna do a reduction over all the indices from 0 to the size of a, right? And this reduction is going to be an anonymous function you call, right? You're going to have two. The thing you return is going to be what this new sort of accumulated value is going to be, and what you're going to return is you're going to associate with a certain key within this map, and the association is going to be. I did this wrong now. It's key to value, right? So it's actually. I wonder if I should use a let first. Maybe there shouldn't be an anonymous function here. Yeah, maybe not. Let's just name it. This is going to be. How would you call this? Accumulate indices, or accumulate, I guess, something like that. And it'll be pseudo anonymous. It's not really anonymous, but because this is named here, we name this anonymous function. And we'll take xy, we'll say index, we'll say collection index, or just, yeah, map index, or m index, probably better. What we're going to say is what you return is m index. Right, so this map, we're going to associate to this map, we're going to conjoin, or conjoin, get from this map this index. Now that's not what we want. We want, right, we want to use a let. See, that's why I wanted to put this over here. I want a let. I'll come back to this shortly. Okay. Yeah, I'm still kind of getting the hang of things with the functional programming and Clojure and all that. So we want to do, say, okay, we're going to associate m with another key and value, right? And that's what we want to return ultimately, right? And that's what our accumulate function is going to do. But what we want to do in particular is get the array value, and that is going to be get the index. It's not the index, it's, yes, that is what we want. That is actually exactly what we want. Get m index array value. Okay, good. Now that we got that, we can say you're going to conjoin get from m, not the index, but the array value. And if we don't have anything in the map, then we want to use an empty set, an empty vector. Then we're going to conjoin with that empty vector, not the array value, but the index here, right? Yeah, I kind of want to name these things because it gets a little confusing. So this is going to accumulate the indices. So now we can reduce over this accumulation. All right, nice. Now what we want to do is say key map to min distance. So what this is going to look like is or even, let's do this way. Let's get distances, or just distance, yeah, distances, or even difference, yeah, diff, just, right, take the diff. This will be a function that takes an array, and what it's going to return is, it's going to be a reduction, I think. Reduce into this array by how does this work exactly? Creates this new array, conjoins. Should be a reduction. Not sure if the reduction is really what we want. I don't think so. I think it's an into is what really what we want. Into. And it's going to be over range of. It's really a map actually. When I think about it. Yeah, it's actually just a map of let's take the range over the count of array. Alright, take that range and we're going to map. No, it's not a map. What is this? This is I mean, well, yeah, maybe it is. Maybe it's just a reduce. Yeah, okay. You just reduce. Okay. All right, and this function is going to work by, use another anonymous function, I guess. 1, 2, we want to say get this is confusing as heck. Number 2, you're going to get number 2 incremented of number 2, and what you're going to do is the difference between these two. Right. Okay. This is going to be conjoined with 1. This result. Have another anonymous function here. Just do this, it's fine. I don't know why this takes me so much time to write out. I don't really like that. I think it'll over time it'll kind of get more comfortable. Like this is why you practice it, kind of a thing. The more I practice it, the more comfortable I get. Yeah, so this should be here. So we get this anonymous function. This takes you're going to conjoin this 1 with a new value. This new value is the difference between take the difference between the index, the next index, and the index you're looking at, and that'll be the difference, and then conjoin that difference with this, this value you're accumulating over, yeah, the initial value will just be empty. And right, so this will take the difference. Jeez, it feels like it just took a lot of typing for something so simple, but I don't know. Could also just be how I'm doing these things. So first we're going to get our keys to, we're going to have to define this accumulate function, get our keys to indices, then we're going to get this diff function that we've created. Now we're going to apply the diff over all of the thing we want though is another reduction over the map, right? So this is going to be, can actually do this out here now. I think you do 2 of these. So the reduction over the map would look like key to indices, and that's in the, right, that's the, this is wrong. The initial state here is map, is the initial map. So the reduction we're going to perform over the keyed indices is another anonymous function, huh? I guess. Keyed indices is the initial state. What we want, probably the keys of keyed indices. Or even the values. I'm not sure if you even need the indices. Yeah, I don't think it matters anymore. Really, once you've got the values, actually this might be interesting. So we could take this anonymous function. We could take diff of this function, and then we could take the minimum of this diff, right? And then we could, I think, we'd reduce again. Another, just apply min over this result and return that, and that should solve the problem. Kind of involved, man. Kind of involved. I don't know. How do I feel about this? Also, it took me a really long time to type out. It took me a while. I'll admit it. It took me a while and wasn't even correct. Values. Clojure map values. Vals. Nice. Proper programmer here that wrote this language. Who's the UE vals? I know what vals are. It's pretty funny. Associationarity. ASOC. Oh. Yes. What did I do wrong? Ah. I knew it, or I thought so. Okay. Yeah, that's what right. That was the mistake. Or at least one of the things. Like, this is why I decided to put this get m in index and get m of index and put it, give it a name, because it appears twice here inside of this conjugation, which is conjoin, which is really just confusing. It's a lot clearer what it does now. A lot easier to understand what you're looking at. Wrong answer. Nice. 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 All right, let's print some of this stuff. So let's print this. Ooh. Okay, what do we end up with here? What arguments here. Excuse me. Oh, okay. Got it. Got it. Key to indices. I don't know what to call this. It really should just be like the index map or something. Nil 0 1 2 3 4 5. Are you kidding me? What? Oh. Oh. This is a function. Accumulate. I probably should actually. I don't know what to call this. It kind of should be anonymous. I'm wondering if there was some, what's that called, a collision? Some name collision or something. No, not a name collision. Oh, that's why. That's why. Okay, got it. I see the problem. This is kind of interesting. It's not M, it's A of index. This is going to be interesting. Two arguments passed to main. Min distance argument 44, function 144. Reduce min diff. Oh, also, yeah. We would say the minimum, right? So this would be like infinity or something. Clojure infinity. No, it's not really reduce even. We're trying to do is a map. Take that back. Yeah, it's a map. Another reply even. One past the core get. Oh, I want to get from array. So, yeah, it's gonna take some time to get familiar with all this. That's okay. Persistent vector, wrong number of arguments passed to persistent vector. Where? 3913. This one. Excuse me. Excuse me. Oh, I don't know why I have 1, 2 in here. Yeah, I made that mistake before as well. I kind of just enumerated that there's going to be 2 arguments without really thinking. What was it doing there? Persistent vector cannot be cast in number. Compiling 3913. Hold on a second here. Okay, so we get 7, so 0, 5, 1, 4, 2, and 3. Okay, got it. And then, right, we're going to take the difference of each of these. And now if we map, that's working as expected. I think if I did this in Python, it would have been done a while ago. But again, that's more because I'm just familiar with Python. It's not really for any other reason, I think. There we go. That's what we wanted. 2 and 3. Oh, I think I see the problem. Okay, that makes some sense. Yeah, alright, got it. Okay. Understood. Taking the min of this, it doesn't make any sense. Yeah. If they're empty. Right. Although this did work. Just didn't. Huh. What does diff do if we... Yeah, it's just empty. Right, that's fine. I know what to do. Okay, I have an idea. Let's just map diff to each of these. Right, return that. And then what we're going to do is apply another map. Or reduce, I guess, which is what I want to do is just filter. Yeah, just filter. I don't know what to do. I have an idea. Filter these values. Result of this. Alright. We're going to filter this and say predicate we're going to use is empty. Alright, and not empty. Okay, okay. How about that? Oh boy. Alright, about not empty. Or just even identity. Just truthy. Try that. See how that goes. No. Come on, man. Clojure not empty. Oh. Okay. Yeah, the truthiness. Let's go. There we go. All right, that's what we wanted. And then finally, we're going to apply min to all of this. And that ought to do it for us. That ought to do it. Okay, guess not. Oh, that's why. Ah. Gotta map min one more time. So really what you want to do is filter not empty, min, and you want to use this macro. Yeah, something like this. No, it's not. It's not. I'm missing something here. Something's missing. No. Because if you filter not empty, you can't just apply min here. Because you're taking min of each. So, wait, what does this do? I don't know. What does this do? No, I'm not even sure. Alright, what happens? I don't know, now I'm just not sure. There's a lot of processing going on, a lot of stuff. I sequence from Clojure not empty. Oh, come on, man. Yeah, this doesn't make much sense what we're doing here. And, alright, we want to filter. Then we want to map the minimum to each of these. See what that looks like. Okay. Now that's the part that's kind of tricky, is that you still have 5353 after you map min to these. Now this I don't completely understand. Why? Time for bed. Out of time. Out of time. Shouldn't this be a bunch of integers now? That's the part I'm super confused about. Why would this not? Each of these elements what? No, why? What? Huh? What do you mean? What? That's not good. I think what you need is this. I think that's what you need. Confusing as that may be. Oh boy. Maybe you need a partial. confusing as well. Oh boy. There we go. That's what we want. So you want to actually extract the minimum from each of these vectors. And then, that was the part that I was missing before. And then you want to take the minimum of these, so all of this. This looks like this. Which is the result they're after all. Output 3, okay. So what this looks like, by the way, is this function of mapdiff you can just pull one of these mapdiff filter not empty partial apply min. You're gonna map that. Confusing as that may be. And then apply min at the bottom. So, and this is all going to be on vals of key to indices and then vals. Okay. Does this work? No, absolutely not. Don't be ridiculous. Yeah, so this is one of those macros. Let's find out which this. So this is called threading in Clojure. It's like a composition kind of thing. The thing I'm wondering is where am I failing here? Like, should this not work correctly? Can I not just simply use this? Oh, it does work, okay. So somewhere along the lines we have a failure though. Oh, right there. Okay. This I think needs to be a partial. Otherwise you can't simply apply it. Oh no, I know why. No, I take that back. That's not the issue. The issue is there's a diff in between. Why did I put a apply min here? Oh, because this is the wrong direction. Of course, that makes sense. It goes top to bottom. Duh. Okay, which ones are incorrect here? Let's find out. This one's fine. This one is probably fine as well. No. I think you need a partial for the map. Now I'm wondering if the thing that's kind of tricky is like we're applying these in sequence to a collection. Some of these generate new collections. How these things generate new collections though is kind of interesting. I wonder. I mean, we can leave it as it is, but I feel like we're not using it exactly how it's intended to be used. Not empty. Yeah, it feels like all of these become partials that we're applying, which is rather confusing, you know? Min. Like, this works, I think. My output partial. Debug output. Yeah, definitely. Can we not apply? Like maybe we just need this if we do it this way. I don't know. Confusing. So certainly confusing. Maybe we just need min after all. I don't know. I don't get it. I kind of want to like reduce this or something. This would be the reducing function. It's more like a transducer is what we want. Well, keys and indices applying vals is fine. We can't just do map diff here because why not? Why can't we do this? What happens if we do this? Partial. What do you mean? What do you mean? Doesn't this apply the... I gotta stop scratching my head. Don't know how to create sequence from minimum distances diff. Oh, what the heck, man? What is this? What is this? What does this even do? What does this even do? Applies as the second argument. Oh, that's very confusing. It's the result, though, is the second argument. This should be fine. This does not work the way I expect it to. If we map this difference onto the results, like this works. But this, for whatever reason, doesn't work. And I don't get it. It actually says illegal argument. Create an I sequence from... What do you mean? It's not a sequence? The map? What are you talking about? What does this do? If we diff, what happens here? That doesn't make any sense. So it'd be why we practice. This is why you practice. It takes time to get comfortable, time to get familiar. So the result of this then gets piped in. I don't understand, you know? Just don't get it. Can we just print line, maybe? Excuse me. How about this? Okay, it works. Prints this. Alright, that's fine. Now the question is, why not be able to, why not map? Why not have it make a partial function, which is map diff? Like, what happens if we do this? What do we get? You get this partial object. No, that doesn't make any sense though. Maybe it's got to be like this. Maybe this is the issue. That might be why. That would make sense. No. That doesn't matter at all. What is going on? Excuse me. Oh. Oh. That was the problem. Oh, that's why. I know what the problem is. Alright. I feel kind of silly now. I got it. Never mind. I'm just... Okay. That was extremely confusing though. So this operator, there's a difference between this one and this one. The difference is this will... Excuse me. Excuse me. Oh, I'm sorry. Coughing right in the mic. Sorry about that. The different... I don't know what just got into my lungs, but a lot of coughing suddenly. The problem is that whatever function you've got here at the in between, with this, it's gonna this whatever you enter, it's always gonna come right next to. It's gonna be the first argument to whatever this function is. So if you make partial, I was gonna say partial with this next. And that's why I kept getting partial functions here. Whereas if you use this operator, so one of these is sort of like the second, and the other one is the last. Second argument position and the last argument position. And this has got it's called the threading macro. It has nothing to do with typical like concurrent threads. But yeah, so with this threading macro, right, we get, now this is always going to be on the rightmost side of the function, the argument list. So now this should work as we expected it originally to work. So we probably don't need all these partials. I was using partials because I was getting really confused, but I think the only one that we really need a partial for is probably this one in between. Because what we need to do is map to, so this gets the values, each array, a sequence of these arrays, which have numbers in them. Then we take the differences over these arrays, right? Some which would actually empty out some of these arrays, remove the empty ones, and then we're going to map to each of these arrays this function, which is partial apply, which if you just did apply min, this would try to apply to this function which there's no argument, so this would fail. But if you use partial, then you can create a function that applies min. Excuse my coughing. Not sure where that came from. This is kind of like creating an anonymous function that will apply min to your arguments. Oh my goodness, I don't know what's going on here. Oh. And then, so you apply min to each of these arrays, and now they're no longer arrays, now it's no longer a sequence of arrays, but it's a, what's that called? A sequence of integers. And now you can apply min over the sequence of integers. Yeah, the result here. And that should do the trick. Let's see what we get if we do that. Again, I realize how long this is taking, but it's, I guess it's sort of involved. Oh no. Passed this test, but what about this one? No arguments passed to core min? Really? Zero, 1, 2, 3, 4. Oh. Oh, I see. Expect an output never -1. Ah, and then finally, apply min. Actually get an exception. Filter not empty again, I guess. Actually, what do we get if we do this? What happens here? Lazy sequence. Exception. Really? First step, vals, map, diff. Alright, so this is vals, diff, empty, not empty. Ah, okay, that makes sense. And then here you would just say an if, and not continue the rest. Excuse me. You could also do this anonymous function that says if empty, return -1, otherwise apply min. Could do that as well. and then apply the minimums of these things. I should do it too. What? What happened here? I guess you don't filter if they're empty anymore. Just, if it's empty, give it a -1. If it's not, then what is going? Come on. Is this a joke? Okay, we're not doing this. Doing it this way. We're doing it this way. I've had enough. I have had enough. Come on, man. Zero 5 1 4 2 3 and then empty. Okay, what? Vals print, diff print, and then what is this? What? How do we get empty? It's just empty after that. Excuse me. If this collection is empty, I'm gonna map this function. These are collections, yeah? If it's empty, turn -1. Otherwise, apply this minimum. But it doesn't return anything, it just returns. I am utterly confused. Excuse me. Let's map this function to sequence of 1, 2, 3, 4, right? Something like this. What does this give us? It's confusing as heck. This does not do what I think it does. Lazy sequence cast to a function. What? Map. It's got to be this anonymous function. It's got to be written incorrectly, something like that. Excuse me. Let's just have an anonymous function that just returns, I guess, 5. Let's see if that works. Returns a constant value. Oh man, I need to sleep. This is not good. Also, this constantly like hitting the run just to see if it works properly. This probably should be done locally if I don't really don't know what I'm doing with this. Yeah, this is not. Why does this not do what I think it does? Do we not? How do we return 5? How do we have a? I don't know. I don't know what's going on, man. This will work though, right? Oh my goodness, come on. What is going on, man? Ah! Doesn't this return something? Is it because I'm trying to make a sequence out of it? Really? It is. Nice. Okay. Try again. Go again. We go again. Okay. No. I don't know what the problem is with that. Yeah, it should be done in a REPL. Select back and forth, just testing syntax. Uh-huh. I see, number of args passed. Priority exception. So okay, how about this? There we go. 1, 3. Okay, that makes some sense. All right, let's get back to what we were doing here. So the issue appears to be okay. So if empty, then -1. Otherwise, oh, I think I see the problem. Well, this works. Right. Let's do empty. Yeah. So what's the failure point here? Oh no, that works. That works fine. Oh. What? Huh. So these should be 1 over, I guess. Something like that, I don't know. Why these aren't just... Oh. I don't know. Oh, I see why. Because we added a character here. But... That's what I had. I don't get it. Why is this not... Why can't I just map this? This is a function. It's an anonymous function. This is definitely a function. Oh, because print line is, that's why. Duh. It's print, okay, never mind. I know what the problem is. This is ridiculous. It's like, come on, man. What is going on? No. No, it doesn't matter. What the freaking heck? No. Okay, whoa. Yeah, this is due to a lack of familiarity with the language. All right, it works. There we go. That's what I wanted. Okay. So actually, the problem is the Heisenberg. It's the Heisenberg uncertainty bug. If you check for the values, then you're gonna get a bug. But if you don't look at the values, you won't get a bug. You'll get an exception. Or if you print the line, you'll get an exception. But if you don't look, you don't print the line, you won't get an exception. The Heisenberg. It's pretty funny. It's pretty funny. Now, the problem with this approach is -1 is probably not what we want to use after all. I think what we're going to want to use is actually another idea. Okay. This should come after, I think. There should be a filter, which is empty, or not empty. All right. Filter that's not empty. Get the difference set. Apply the minimum. Yeah, that works. Apply the minimum after taking the difference. It's bound to be, no, it could be empty. Right, no, filter if it's not empty, it's empty. Right, so, okay. After taking the difference, filter on the things that are empty. Then get the minimum of the things that are not empty. Now the things could be empty here. So these are now all the minimum values. Now you could have no minimums because all the things you filtered everything out. So all of your differences could be empty sets. Some of them could be empty, some of them not empty. Okay, that's where it gets interesting. All right. So you don't really necessarily want map. You actually want something a little more. Okay, watch this. It's the other way around. It's if. Wow. Okay, check this out. If. It's an anonymous function, which says if the sequence is empty now, then we're going to return -1. Otherwise, we're going to go ahead and map this partial function to the sequence. Which is not even. Holy guacamole. Yeah, it's pretty involved, huh? But I think that's what we want. Is that if after we filtered out the empty stuff, if it's still empty, then we return a -1. If it's not empty, then we're going to map to each of these. Now it's a sequence of vectors, right? So we're going to map to the sequence of vectors, the minimum function. So each vector will get the minimum of each vector. And then we can apply minimum again. and we should be good to go. Wow. It doesn't seem like so many steps, but it's kind of involved, huh? Oh my goodness, please. Oh, you gotta be kidding me. What the heck? I don't like this at all. I don't like it. I don't like it. I can't use this anonymous function here. It's not gonna work, huh? Okay. Let's see what we get here. No doubt this is the root of the problem here. Lazy sequence. Okay. So if it's now again, it's a sequence of vectors, right? So if this sequence of vectors is empty, turn -1. Otherwise, we're going to map to each of the values in the sequence, which are vectors, the apply min to that vector, that collection. So we get the minimum of that. Why am I getting errors? What is going on? Excuse me. Don't know how to create iSequence from. I don't think that's the problem. Oh. Oh, I see. Okay. Why? I'm really confused. Why would this not call the function with this? Is that the problem? Do we need to encapsulate this? Is that it? Does that make sense? It doesn't make. Oh, I guess I understand now. Okay, got it. Okay, that worked. Pass to apply number of arguments. This is partial now. Nice. So this is super confusing. The reason why you need to encapsulate this into parentheses is nice. Oh wow, that's extremely confusing. So the reason why you're going to encapsulate this in parentheses is because if you think about how this macro works, like there's a function encapsulated in parentheses. So when we define the anonymous function, we need to actually call it also. Defining it here is not the same thing as actually using it. So you gotta wrap it in parentheses. And then, right, if this thing is empty, so then we get past this. So it gets kind of placed inside these parentheses. So if it's empty, return -1, otherwise you're gonna map to it now. This has to be a function, this partial apply min, otherwise you're gonna try calling apply on something so it has to actually make this a partial as well. I realize it's really confusing, but something that I think you get used to over time, you get familiar with over time after some practice, which is what we're doing while we're doing it. So, wrong answer. You've got to be kidding me. You've got to be freaking kidding me. Are you serious? Alright, print it. Show me. Show me what we end up with now. What? What? Doesn't this return something? I'm most confused. What is going on, man? -1. Oh, okay. No, that's fine. 5-3. Got it. -1, 5-3. Oh, I understand. Ah, I got it. This doesn't have a way to short circuit this either. Excuse me, just kind of, well, in that case, you can just do this. This works too. That's good enough. I was gonna say we could find a way to short circuit this, but there is a way to do it, but we're not gonna do it here using a reduction. Leave this as it is. Yes, that took a very long time to get that right. Really not necessary to take that much time. This is considered an easy problem, but obviously we're still learning the language, so it's going to take us a while. It's kind of what we expect for some time as well, as we get more and more familiar. Where is this output coming from? This debug output. There's a print line somewhere here that I got to get rid of. Ah, there it is. Overall pretty simple algorithm. Like I said, in Python this would be like one line. I guess you could rewrite this in Clojure as one line as well. You can plop this in here and here, and that gives you this line, which is the ACC, which you can put here. Make this an anonymous function where everywhere you see m and index, you can just replace with, you know, %1, %2. So that would be one line here. And then this keyed indices you can just put here, right? It's one line. And then this diff, you can create another sort of anonymous function, which is this reduce. No, yeah, you actually just take this whole thing, make it one line as well, put that right here. And then you can, yeah, one line, right? This would be just a few lines. You could do that too. It would be a lot less legible, a lot less readable, but it would be technically correct. If this is correct, which we'll try right now, find out if I didn't make any mistakes, anything silly. Nice, got there. Awesome. Okay, so let's go ahead and we should go to so that was the 6th problem. Well, I'm counting backwards. Let's say this is not the 6th problem. Let's say, I shouldn't be saying it that way. I should say this is the 4th problem. Which now would be, oh, okay, well now would be on the 5th. But yeah. So, in the other videos, I was like counting backwards for some reason without clarifying that I was counting backwards. It probably sounded kind of confusing to folks. We want to do 10 problems. We did 1, 2, 3. This is the 4th problem we did so far in Clojure. And a lot of this is just like getting familiar with the syntax. 5th problem coming up soon. 5th problem coming up soon. Yeah. Yeah. Okay. Tomorrow I'll probably look into more questions, more stuff. I don't know if I want to keep doing easy. I guess easy problems would probably not be a bad idea. Gotta get familiar with the just the general, like using reducers in the map functions and whatnot. I do eventually need to start using transducers as well. Those are relevant, and that I was describing a way to kind of short circuit the calculation. You can use a reduced, so in your transducer you can use a function that will short circuit your loops, so to speak, your recurrences. Also, at some point, I would like to show you. I'll probably make a video about this, about like the Y Combinator function what the value of that is, how to use that, what that is. It's pretty neat, but we can go into that another time as well. Kind of want to dedicate some time to like showing off what the Y Combinator can do, how to use it, and kind of giving a vague idea of like how it came to be, how it was derived. That could take some time though. I don't know how long. If I could maybe try to make a 10-minute video, try to shorten it to make it something like kind of some explanation. Yeah. All right. So thanks for watching. Talk to you soon, and tomorrow we'll try to get through. So this was problem number 4. We'll try to get through the other 6, the next 6 problems. So yeah. Take care. Take care.